Hello there. In this video we're going to talk about solving equations using properties of logarithms. And here we have the first one. The first one is called the power rule. Okay, and it says if you have a number raised with an exponent inside a logarithm, you can put that exponent out in front and it's not going to change the value of the logarithm. So the rest of it's unchanged, just that n goes from being the exponent to being out in front. Now the next one we call the product rule. Okay? And not because of how it starts, but because of how it ends. Okay? We have log base A of B plus log base A of C equals log base A of B times C. It says if you have two logarithms with the same base and they're being added together, you can actually put those two logarithms together and multiply their insides. Everything we do with solving comes down to, can we make this smaller? Can we condense the equation or the expression? So if we have a product rule, you know there's a quotient rule that's going to be following. So again, if you have two logs with the same base and they're being subtracted, it says you can put those together and write them as the first divided by the second. So if it's B minus C, it's technically B divided by C. So log B minus log C is actually log of B divided by C. So let's see how we're going to use these. I'm going to start with the power rule. Okay? And so here I have log base 2 of 16x to the 5th equals 40. Now, I could, find 16 to the 5th power and x to the 5th power, and that would be totally fine. But I can make this problem a whole lot easier for myself if I use the power rule. So if I have an exponent, I'm going to kick it out front, just like you see there. Now, I want to get x out of this log, so what I got to do is get the log by itself. So I'm going to divide both sides by 5. Okay, and that's what we see right there. Now, 40 divided by 5 is 8. So now I have a log equal to something that's not in a log. So, whenever that happens, I convert to exponential form. So the 2 is going to become big, and these pieces here are going to crisscross. So that gives me 2 to the 8th equals 16x. Well, 2 to the 8th is 256. So I'm just going to divide both sides by 16, and x is 16. That's an example of the power rule. You're welcome to review this and go back, okay? But because I'm trying to keep the video as short as possible, I'm going to move on. The next example is going to be an example of the power rule. So here's our problem. Log base 5 of 5x squared plus log base 5 of 9 equals 1. Now, I can't really, without a whole bunch of algebraic manipulation, move this 2 to the outside because there's also a 5 here. Okay, if they were both, 5x quantity squared, I could do it, but I can't do that right now. So, but because it's plus, I can put these two together, okay, and multiply the insides together. So I get log base 5 of 5x squared times 9 equals 1. So I'm going to clean that up in the next step. 5 times 9 is 45. Now, I have a log, and I have a number that's not in a log. So I'm going to switch to exponential form. Okay, so the 5 becomes my large base, the 1 becomes the exponent, and it equals 45x squared. That crisscross relationship is still present. So now I'm going to clean it up just a little bit. 5 to the first is 5. I'm going to divide by 45. Okay, as you see there. 5 divided by 45 is 1/9. Square root both sides now to get x squared, so it's just x, and that gives us positive or negative 1/3. Now, you should, because I have a negative number here, you should plug that back into the original equation to make sure this is positive. Remember, you cannot take the log of 0, okay, and you cannot take the log of a negative number. So, you have to double check that. Now, negative 1/3 squared becomes positive, and that's all I care about. 5 times 1/9 is a fraction, but I don't care. So the next rule is the quotient rule. Okay? Now here I have natural log of x plus 26 minus the natural log of 7 equals the natural log of 2x. So because this is minus, I'm allowed to condense this into one logarithm where I divide. So x plus 26 over 7. Okay. So the log of x plus 26 over 7 equals the natural log of 2x. So what I can do, because these are the same logarithms with the same base, I can drop the logarithms. And I can just solve this now. X plus 26 over 7 equals 2x. So I'm just going to multiply both sides by 7. I'm going to get rid of that big fraction. Okay, and there we are. Multiplying both sides by 7. So 2 times 7 is 14. And over here the 7's cancel. So I'm left with just x plus 26. So now I have to decide, what do I need to move, the x or the 26? Well, there's x's over here, and I want to get them all on one side. I do not have any constants, so it's foolish of me to move the 26. So, moving the x. So I subtract the x from both sides. Okay, so these two cancel. 14x minus x is 13x. So I get 26 equals 13x. Well, when I divide by 13, I get x is 2. So, the three properties that we have to focus on are the power rule, the sum rule, and the quotient rule. And in review, here are those properties again. Okay. Have a good one.